Tonight, we're drifting into some of the strangest mysteries hidden in the universe. From dark matter and black holes, to alien worlds and unexplained signals from deep space. The more humanity explores the cosmos, the stranger it seems to become. Before we begin, leave a comment telling me what city you're watching from tonight, and what you think is the biggest mystery in space. Do you think humanity is truly alone? And if you enjoy relaxing space documentaries like this, don't forget to subscribe. Now get comfortable, and let's slowly drift into the universe tonight. Night came differently to the ancient world. Thousands of years ago, long before highways, skyscrapers, or glowing cities covered the earth in artificial light, darkness arrived completely. The stars did not appear as a few faint dots scattered overhead. They flooded the sky in impossible numbers. The Milky Way stretched from horizon to horizon like a pale river across the heavens. Some stars flickered softly, others burned with unusual colors. Planets wandered slowly through the darkness, unlike every other point of light. Meteors flashed without warning and vanished before anyone could fully understand what they had seen. For ancient humans, the night sky was not background scenery. It was alive. And perhaps the strangest part is that nearly every civilization on Earth became obsessed with it. The Egyptians watched the stars. The Maya tracked planets with astonishing precision. Ancient Chinese astronomers recorded celestial events for centuries. Polynesian navigators crossed entire oceans using nothing but memory, waves, and starlight. Even cultures separated by thousands of miles often arrived at the same unsettling conclusion. The sky meant something. Exactly what it meant depended on the civilization. But almost nobody believed the stars were random. That idea alone says something profound about early humanity. Before modern science, before telescopes, before electricity, humans were already looking upward and searching for patterns hidden inside the darkness. Some researchers believe this obsession may be older than civilization itself. In southern Turkey stands Göbekli Tepe, a site more than 11,000 years old. Massive stone pillars arranged in circles rise from the ground, carved by humans who lived before writing even existed. Archaeologists still debate the true purpose of the site. Some researchers have proposed possible astronomical alignments connected to ancient skies or seasonal observations, though no universal agreement exists. Still, the possibility changes the feeling of the ancient world entirely, because it suggests humans may have been carefully watching the heavens before cities, kingdoms, or formal religion fully emerged. Curiosity about the stars may be one of humanity's oldest instincts. And once people began studying the sky, they noticed something unusual almost immediately. Not all stars behaved the same way. Most remained fixed in stable patterns night after night, but a handful moved slowly across the heavens. Ancient observers called them wanderers. Today, we know them as planets. Mercury, Venus, Mars, Jupiter, Saturn. To ancient civilizations, these wandering lights felt mysterious because they broke the rules. The stars stayed organized. The planets drifted. That difference made them powerful symbols. Mars became associated with war because of its red color. Venus often represented beauty, fertility, or divine femininity. Jupiter moved slowly and brightly enough that many cultures connected it with kingship or gods of authority. Even now, thousands of years later, those planetary names still survive inside modern language. Ancient humans were not merely observing the night sky. They were building entire systems of meaning around it. The Maya became particularly famous for this. Deep in Central America, long before European contact, Maya astronomers developed calendars capable of tracking celestial cycles with remarkable precision. Venus was especially important. Some Maya records tracked its movements so carefully that certain calculations differed from modern measurements by only tiny margins. And what makes this more impressive is the environment where they accomplished it. Dense jungles, humid heat, no telescopes, no computers, only generations of patient observation. At sites like Chichen Itza, sunlight and shadow still interact with pyramids in ways that appear intentionally connected to celestial events. During equinoxes, shadows create the illusion of a serpent descending a staircase. Whether every alignment was symbolic, religious, astronomical, or a combination of all three remains debated among scholars. But one thing feels clear. The sky was deeply woven into how these civilizations understood reality itself. The Egyptians saw something similar in the stars above the Nile. For them, the heavens were tied closely to eternity and rebirth. Certain stars disappeared below the horizon and returned seasonally, almost like cosmic proof that death itself was temporary. Sirius became especially important because its appearance in the dawn sky closely matched the annual flooding of the Nile River. And the Nile flood meant survival, food, life. In that world, astronomy was not abstract curiosity. Watching the heavens helped entire civilizations function. The Great Pyramid of Giza still reflects that relationship with the sky. The structure aligns remarkably close to true north, and some internal shafts appear connected to stars important within Egyptian cosmology. Over time, theories surrounding the pyramids became exaggerated online, with claims ranging from lost civilizations to impossible technology. Most archaeologists reject those extreme ideas. But even cautious interpretations acknowledge something fascinating. The builders clearly cared deeply about celestial alignment. The stars mattered enough to shape monuments meant to last forever. And perhaps that connection between stars and eternity explains another strange pattern found across ancient cultures. Again and again, humans linked the night sky to death. In Greek mythology, heroes became constellations after dying. Ancient Egyptians believed souls could ascend into the heavens. Some indigenous traditions viewed the Milky Way as a path traveled by spirits after death. In parts of Asia, certain stars became associated with ancestors watching from above. This pattern appears so often across unrelated civilizations that it raises an interesting possibility. Maybe humans instinctively connected the heavens with something beyond ordinary life, because the sky already felt unreachable and eternal. The stars outlived generations. Empires collapsed beneath them. Yet the constellations remained. Even comets terrified ancient observers, partly because they disrupted that permanence. Unlike stars, comets appeared suddenly. They moved unpredictably. Some grew brighter night after night before fading away again into darkness. Ancient Chinese records carefully documented these strange objects for centuries. Roman writers often describe them as omens. Medieval Europeans sometimes connected them to war, plague, or divine punishment. And honestly, it is easy to understand why. Imagine living in a world where the sky is believed to be stable and eternal, then suddenly witnessing a giant glowing object hanging overhead where nothing existed before. The heavens themselves would seem disturbed. One of the most famous examples arrived in 1066, when Halley's comet crossed the sky shortly before the Norman conquest of England. Many interpreted it as a warning of disaster. Yet, the comet itself was simply following a predictable orbit around the Sun, something humans would only understand centuries later. That detail reveals something important about the history of astronomy. Ancient people often observed real phenomena accurately, long before understanding what those phenomena actually were. The same thing happened with exploding stars. In the year 1054, Chinese astronomers documented a brilliant guest star, bright enough to remain visible during daylight for weeks. Modern astronomers later realized they had witnessed a supernova explosion whose remnants became the Crab Nebula, which means ancient humans once watched a star die in the sky without fully knowing what they were seeing. There is something haunting about that thought. A civilization staring upward while an entire distant star destroys itself across space. And in some ways, humanity is still doing the same thing today. Because even modern science continues discovering objects stranger than earlier generations imagined possible. The Milky Way itself once confused ancient observers. That glowing band across the night sky inspired myths across countless cultures. Some saw it as a celestial river. Others imagined spilled milk from the gods. In parts of South America, certain indigenous traditions focused not on the bright stars inside the Milky Way, but on the dark spaces between them. That detail is surprisingly fascinating. Modern astronomy later revealed many of those dark regions are enormous clouds of cosmic dust where new stars form. In a strange way, ancient people had unknowingly attached meaning to areas of the sky modern science would later discover were physically important. The darkness mattered too, and perhaps nowhere does human understanding of the stars feel more impressive than in the Pacific Ocean. Long before compasses or satellites existed, Polynesian navigators crossed enormous stretches of open sea using stars as directional guides. They memorized rising points of constellations, seasonal sky changes, ocean swells, cloud formations, and bird movements with astonishing precision. Some voyages stretched across thousands of miles of empty ocean. At night, the sky became a map. Modern researchers studying traditional Polynesian navigation often describe it less as primitive survival and more as an advanced knowledge system built entirely from observation and memory. And honestly, that may be one of the most underrated achievements in human history. People crossed one of the largest oceans on Earth, guided mainly by patterns of light above them. The stars were trusted with human lives. But perhaps the deepest mystery is not how ancient civilizations studied the sky. It is why humans feel emotionally affected by it at all. Even now, modern people living under electric lights still pause when they see a clear sky filled with stars. Something about space changes the scale of human thought almost instantly. Problems feel smaller. Time feels deeper. The universe suddenly seems both beautiful and unsettling at the same moment. Astronauts have described similar feelings after seeing Earth from orbit. Many experience what psychologists call the overview effect, a powerful shift in perspective triggered by viewing the planet suspended alone in darkness. Borders disappear. Conflicts feel temporary. Human civilization suddenly looks fragile. Maybe ancient people felt something similar beneath untouched night skies thousands of years ago. Perhaps that emotional reaction shaped civilization more than we realize. Because astronomy influenced calendars, agriculture, navigation, religion, mathematics, architecture, and eventually, modern science itself. Entire societies organized life around celestial cycles. The sky was not decoration. It was structure. And yet, despite thousands of years of observation, humanity still understands only a tiny fraction of what exists beyond Earth. The stars ancient people stared at with awe are merely a small part of one galaxy among hundreds of billions. Some of those stars no longer exist. Their light is still traveling, which means, in a way, humanity has always been looking into the past whenever we look into the night sky. And perhaps that is why the heavens still feel mysterious, even now. Because the deeper humans explore space, the stranger it becomes. The ancient world sensed that mystery long before telescopes confirmed it. The sky never truly felt empty. It felt endless. For most of human history, the planets of our solar system already seemed strange enough. A world with storms larger than Earth. A frozen moon hiding oceans beneath ice. The planet surrounded by rings so enormous they could stretch across millions of miles. And yet, the deeper modern astronomy looked into space, the more unsettling reality became. Because it turned out, the universe had been hiding worlds far stranger than ancient humans ever imagined possible. Some planets rain molten glass sideways through the atmosphere at thousands of miles per hour. Some drift alone through darkness without any star at all. Others orbit so close to their suns that their surfaces may glow like burning metal. And somewhere in the distance, there may be oceans deeper than anything on Earth, beneath skies no human being will ever see directly. What makes these discoveries feel especially eerie is how recent they are. For thousands of years, humans did not know whether planets existed beyond our solar system. Even as late as the early 1990s, the idea of discovering distant worlds still felt uncertain. Then, suddenly, the universe opened. Thousands of exoplanets began appearing, and almost immediately, many of them seemed deeply unnatural. One of the strangest worlds ever discovered is a planet known as HD 189733b. At first glance, it might sound beautiful. Scientists believe its atmosphere likely appears deep blue, possibly similar to Earth when viewed from space. But that color hides something violent. Observations suggest temperatures there rise above 1,700 degrees Fahrenheit, while winds may scream through the atmosphere at over 5,000 miles per hour. And according to current models, rain on this world may fall as molten glass. Sideways. The terrifying thing is not simply that such a place exists. It is that the laws of physics allow it to exist naturally. The universe does not seem interested in creating only calm, Earth-like environments. In fact, Earth may be unusually gentle compared to many worlds scattered across the galaxy. Some planets appear almost deliberately hostile. 55 Cancri E became famous partly because early studies suggested it might contain enormous quantities of carbon under immense pressure, leading to speculation about a diamond planet. Later research complicated that interpretation, and scientists remain cautious about describing the planet too dramatically. But even without giant diamonds, the world remains astonishing. It orbits so close to its star that a year there lasts less than 18 hours. Imagine a planet racing around its sun so quickly that sunrise and sunset become almost meaningless. Surface temperatures may rise high enough to melt rock entirely. Some researchers believe enormous oceans of lava could exist across parts of the surface, glowing beneath a dark, alien sky. And somewhere in the middle of all this, another realization slowly emerges. Human intuition about planets was completely wrong. For most of history, people assumed worlds beyond Earth would probably resemble versions of the places already familiar to us: colder deserts, hotter jungles, larger oceans. Instead, many exoplanets feel more like cosmic experiments. Some orbit two stars at once, creating double sunsets that once belonged only to science fiction. Others are so massive they blur the line between planet and failed star. Some appear darker than coal, absorbing almost all incoming light instead of reflecting it back into space. One of the darkest known planets, TRES-2b, reflects less light than black acrylic paint. Scientists believe its atmosphere may absorb nearly everything that reaches it, making the planet appear almost invisible against space itself. And honestly, there is something deeply unsettling about a world that barely reflects light. It feels less like a planet and more like an absence. Yet even these bizarre worlds may not be the strangest environments in existence, because some planets do not orbit stars at all. They wander alone through interstellar darkness. These are often called rogue planets. At some point in their history, many may have formed normally around stars before gravitational chaos eventually hurled them outward into empty space. Others might have formed independently from collapsing gas clouds without ever belonging to a solar system. Either way, they drift through the galaxy without sunrise or sunset. No daylight, no warm seasons, only endless night. And strangely, Some scientists think certain rogue planets could still retain internal heat beneath thick atmospheres or buried oceans. If enough geothermal warmth remained trapped below the surface, isolated pockets of liquid water might theoretically survive despite the darkness above. That possibility changes something important about the search for life, because it suggests habitable environments may not require sunlight in the way humans once assumed. Life, at least microbial life, might survive in places almost completely disconnected from stars. And if that is true, then the galaxy could be far stranger and potentially far more alive than earlier generations imagined. Some worlds may contain oceans so deep that the human mind struggles to picture them properly. Astronomers have identified planets that appear likely to be water worlds, where enormous global oceans cover most or all of the surface. On Earth, water interacts constantly with continents, atmosphere, geology, and climate cycles. But on certain exoplanets, oceans may extend hundreds of miles downward beneath crushing pressure. The deeper those oceans become, the stranger conditions likely turn. At extreme depths, water behaves differently. Ice can form not because temperatures are cold, but because pressure forces water molecules into unfamiliar structures. Entire layers of exotic, high-pressure ice may exist beneath warm, alien oceans, separating liquid water from the rocky core below. In a strange way, some of these planets might contain more water than Earth ever did, while simultaneously feeling far less alive. The universe seems filled with environments balanced between possibility and isolation. And then there are the planets that should not exist at all. Astronomers have discovered giant gas worlds orbiting absurdly close to their stars, places where temperatures climb high enough to inflate entire atmospheres outward like overheated balloons. These hot Jupiters challenged older models of planetary formation because scientists originally assumed giant planets could only form far from their stars, where temperatures remained lower. Yet, there they were, massive worlds orbiting dangerously close to stellar fire. That discovery forced astronomers to reconsider something fundamental. Planetary systems may be chaotic. Worlds move. Orbits shift. Giant planets migrate inward. Smaller planets may be destroyed or ejected completely during these gravitational rearrangements. In some systems, the calm stability humans associate with our solar system may never fully exist. And honestly, that realization makes Earth feel unusually fortunate. Not necessarily unique, but perhaps unusually stable. Some exoplanets orbit red dwarf stars, the most common type of star in the galaxy. At first, these systems seemed promising because smaller stars live for enormous lengths of time. But many red dwarfs behave violently during their early lives, releasing intense stellar flares capable of stripping atmospheres from nearby planets. This creates an unsettling possibility. The galaxy may contain countless worlds trapped in cycles of radiation and darkness, where life struggles constantly just to survive. And still, scientists continue searching, partly because a few planets remain deeply intriguing. The TRAPPIST-1 system became famous after astronomers discovered 7 Earth-sized planets orbiting a single small star. Several appear to exist within the star's habitable zone, where temperatures might allow liquid water under the right conditions. Whether those worlds truly possess stable atmospheres or oceans remains uncertain. The star itself may create difficult conditions through radiation and tidal locking, but the images alone captured public imagination. 7 distant worlds circling together in darkness. Potential skies no human eyes have ever seen. Potential oceans. Potential storms. Potential life. And perhaps that is the most powerful thing about exoplanet discovery. Not certainty. Possibility. Because the farther humanity looks into space, the more the universe resists simple answers. A planet that appears promising one year may later turn hostile under new observations. A world once dismissed as barren may suddenly reveal signs of atmosphere or water vapor. Even the methods used to detect exoplanets often rely on tiny fluctuations in starlight or faint gravitational effects. In many cases, scientists are reconstructing entire worlds from shadows. And yet, despite those limitations, the discoveries keep becoming stranger. Some planets may orbit near black holes. Others might survive inside binary star systems with wildly unstable skies. There are even theoretical discussions about superhabitable planets, worlds potentially better suited for life than Earth itself. Slightly larger planets with thicker atmospheres, stable climates, shallow oceans, and longer-lasting stars might allow ecosystems to flourish for immense periods of time. That idea feels strangely humbling. For centuries, humans treated Earth almost as the center of biological possibility. Now science quietly suggests there may be worlds even more favorable to life than our own. But perhaps the strangest emotional shift caused by exoplanet discovery is this. The universe no longer feels empty between the stars. Before the 1990s, planets beyond our solar system belonged mostly to speculation. Today, astronomers estimate there may be hundreds of billions of planets within the Milky Way alone. Hundreds of billions. Some frozen, some burning, some drowned beneath endless oceans, some drifting alone through darkness, some possibly holding skies where rain falls onto landscapes no human civilization will ever touch. And somewhere out there, there may be worlds orbiting peacefully beneath quiet stars where life emerged long before Earth even formed. Or perhaps many planets remain silent forever. That uncertainty is part of what makes the universe feel so immense. The more worlds humanity discovers, the less ordinary Earth appears, not because Earth is necessarily rare, but because reality itself turned out to be far more creative than expected. The night sky once looked calm from the surface of ancient Earth, but hidden behind those tiny, distant lights were planets with burning rock oceans, collapsing atmospheres, frozen seas beneath ice, endless storms, and darkness so complete it barely reflects light at all. And somehow, this may still be only the beginning of what exists out there. For a long time, humans believed the universe was made mostly of things we could see. Stars, planets, galaxies, glowing clouds drifting across space. It felt reasonable to assume that light revealed reality. After all, nearly everything humans understand about the world arrives through sight. Ancient astronomers mapped the heavens by watching moving lights cross the sky. Early telescopes expanded that vision outward. Modern observatories filled the universe with color, structure, and detail. And yet, somewhere along the way, astronomy discovered something deeply unsettling. Most of the universe appears to be invisible, not hidden behind dust, not too far away to detect, actually invisible. The realization emerged slowly, almost accidentally, through a problem that at first seemed small. Galaxies were spinning incorrectly. In the early 20th century, astronomers began measuring how fast stars moved inside spiral galaxies. Based on ordinary gravity, stars farther from the galactic center should orbit more slowly, similar to planets in our solar system. The outer regions were expected to drift calmly around the edges. But they did not. The stars at the outskirts of galaxies were moving far too fast. So fast, in fact, that galaxies should have torn themselves apart long ago. And yet they remained stable. At first, scientists assumed something in the calculations must be wrong. Perhaps telescopes lacked precision. Perhaps estimates of galactic mass were incomplete. But the deeper astronomers looked, the stranger the problem became. The visible matter inside galaxies simply did not provide enough gravity to hold them together. Something else was there. Something enormous. Something no telescope could directly see. This invisible presence eventually became known as dark matter. Even now, decades later, nobody knows exactly what dark matter truly is. That detail alone makes the modern universe feel strangely unfinished. Scientists can map galaxies billions of light years away. Spacecraft can land on moving comets. Telescopes can detect atmospheres around distant planets. Yet, the substance believed to make up most of the universe remains mysterious. And perhaps even stranger, dark matter does not seem rare. Evidence suggests it surrounds galaxies everywhere. In a way, galaxies may actually exist inside vast, invisible halos much larger than the glowing stars humans normally focus on, which creates a bizarre image of reality. The shining universe people admire in photographs might only be the visible surface of something far larger hidden underneath, like seeing foam on top of a dark ocean without knowing how deep the water goes. One reason dark matter became so difficult to ignore came from galaxy clusters. When astronomers observed enormous groups of galaxies interacting together, gravity again appeared too strong. Galaxies moved as though much more mass existed than anyone could see directly. In some cases, the difference became impossible to explain away. Then, gravitational lensing revealed something even stranger. According to Einstein's theory of relativity, massive objects bend space itself. Light traveling near enormous masses follows those curves, causing distant galaxies to appear distorted or magnified. Astronomers began using this effect almost like a cosmic measuring tool. And again, the numbers did not match visible matter alone. Something invisible kept bending the universe. One famous example, known as the bullet cluster, became particularly important. Two galaxy clusters had collided, separating normal visible matter from the invisible gravitational effects surrounding them. The collision behaved almost like a natural experiment occurring across deep space. For many researchers, it became some of the strongest evidence that dark matter may truly exist as a physical substance rather than simply an error in gravity calculations. Still, not everyone agrees completely. A few alternative theories propose gravity itself might behave differently across enormous cosmic distances. Some physicists continue exploring modified gravity models that attempt to explain galactic behavior without requiring unseen matter. But so far, dark matter remains the leading explanation, which means humanity may be living inside a universe dominated by something we still cannot directly identify. And honestly, that realization feels almost ancient in a strange way. Early civilizations once imagined invisible forces guiding reality beyond human perception. Modern science dismissed many supernatural explanations over time, replacing them with measurable laws and physical understanding. Yet now, astronomy quietly suggests that most cosmic structure depends on something humanity still cannot see. Not magic, not mythology, but still hidden. The search for dark matter has led scientists into some surprisingly eerie places. Deep beneath mountains, detectors sit in silence, waiting for invisible particles to pass through Earth. Massive underground laboratories in places like Italy, Canada, and China attempt to shield experiments from ordinary radiation and cosmic noise. Because if dark matter particles interact with normal matter at all, the interactions appear extraordinarily weak. Right now, as you sit quietly listening to this story, trillions of invisible particles may already be moving through your body every second, without sensation, without resistance, without leaving obvious evidence behind. That idea alone changes how empty space feels. The world around us suddenly seems less solid, less isolated, almost permeable. Some dark matter candidates sound especially unsettling. One theoretical particle, called the WIMP, became a major focus for decades because it fits several cosmological models surprisingly well. Other theories involve ultralight particles called axions, strange hidden sectors of physics, or entirely new classes of matter beyond the standard model. And despite enormous effort, dark matter still refuses to reveal itself clearly. The universe continues withholding the answer. But dark matter is only part of the mystery, because during the late 1990s, astronomers discovered something perhaps even stranger. The expansion of the universe is accelerating, not slowing down, accelerating. For most of scientific history, researchers assumed gravity would gradually slow cosmic expansion after the Big Bang. Galaxies might continue drifting apart forever, or perhaps gravity would eventually reverse the process and collapse everything inward again. Instead, distant supernova observations revealed the opposite. The universe appears to be expanding faster over time. Something is pushing space itself outward. That invisible influence became known as dark energy. And honestly, dark energy may be even more mysterious than dark matter. At least dark matter behaves somewhat like gravity producing mass. Dark energy feels stranger. It appears woven into space itself, stretching the cosmos apart on enormous scales. Current models suggest dark energy makes up the majority of the universe's total energy content, which means ordinary matter, stars, planets, dust, humans, every visible object ever observed, may represent only a tiny fraction of reality. That realization can feel almost psychologically disorienting. Everything humanity has ever touched, built, feared, or loved exists inside the visible minority of the cosmos. The overwhelming majority remains unseen, and the universe keeps getting stranger the deeper scientists investigate it. Astronomers now suspect invisible dark matter structures helped shape the earliest galaxies after the Big Bang. Computer simulations suggest ordinary matter may have gathered around massive dark matter frameworks, like fog condensing onto invisible scaffolding. In other words, galaxies may exist because hidden structures formed first. The visible universe could literally be built upon invisible foundations. There is something oddly poetic about that idea. Ancient people once imagined hidden frameworks beneath reality. Modern cosmology accidentally arrived at something surprisingly similar through mathematics and observation. Not spiritual scaffolding. Cosmic scaffolding. Yet even with all this evidence, enormous uncertainties remain. Scientists still do not know whether dark matter consists of particles, fields, unknown physics, or something even stranger entirely. Dark energy may represent vacuum energy, a property of space itself, or perhaps evidence that current cosmological models remain incomplete. Some theories become even more unsettling. A few physicists have explored the possibility that invisible dimensions beyond ordinary human perception might influence gravity across cosmic scales. Others investigate whether the universe itself behaves differently at vast distances than current theories predict. There are even discussions, highly speculative but fascinating, about whether entire hidden sectors of reality could exist alongside ordinary matter while barely interacting with it, like parallel layers of existence sharing the same universe invisibly. Most of these ideas remain uncertain and controversial, but the fact they are discussed seriously at all reveals how incomplete humanity's understanding still is. The universe has not become simpler with discovery. It has become deeper and perhaps more haunting, because invisible things already dominate ordinary human life in ways people rarely notice. Gravity itself cannot be seen directly. Magnetic fields remain invisible. Radio waves pass through walls continuously. Entire communication networks move silently through the air around us every second. Reality has always contained hidden layers. Cosmology simply expanded that realization to the scale of the universe itself. Some astronomers suspect there may even be invisible galaxies, difficult to detect directly if they contain very few stars. Others search for dark matter streams flowing through the Milky Way, like unseen rivers crossing the galaxy. And then there is the terrifying possibility of what happens if dark matter suddenly vanished. Most galaxies would likely lose the gravitational stability holding them together. stars could drift apart. Galactic structures built over billions of years might slowly unravel. The visible universe may depend completely on something humanity still cannot identify, which means every glowing galaxy in the night sky could be suspended inside an invisible framework nobody fully understands. That idea changes how space feels. The darkness between stars no longer seems empty. It seems occupied, not necessarily by life, not necessarily by anything conscious, but by hidden structure, hidden force, hidden mass shaping the entire cosmos, silently from behind the scenes. And perhaps the strangest part is this: humanity discovered all of it indirectly. No one has ever photographed dark matter itself. Nobody has seen dark energy flowing across space. Instead, scientists noticed their effects: stars moving too quickly, galaxies bending light too strongly, the universe expanding too fast, and realized visible reality was incomplete. In a way, modern cosmology became a science of shadows. Astronomers study what cannot be seen by observing how the visible universe behaves around it, which feels strangely fitting, because throughout history, humans often imagined the cosmos as something far larger than perception allowed. And now, after centuries of exploration, modern science has arrived at a breathtaking possibility. Most of existence may still be hidden in darkness. There are places in the universe where reality itself seems to begin breaking apart. Not metaphorically, not emotionally, physically. Regions where time slows down, light disappears, matter is crushed beyond recognition, and the ordinary rules humans experience every day stop behaving normally. For centuries, black holes sounded almost too strange to be real, more like cosmic nightmares invented by theoretical physics than actual objects scattered throughout space. And yet, the deeper astronomy looked into the universe, the more unavoidable they became. At the center of galaxies, inside collapsing stars, hidden within violent gravitational storms across deep space, black holes appear to exist almost everywhere, which raises a disturbing possibility. The universe may be far darker and more extreme than it first appears. The strange story of black holes began long before anyone used the term itself. In the late 18th century, a few scientists wondered whether gravity could become so strong that even light might fail to escape. The idea sounded bizarre at the time because light itself was not fully understood yet. Still, the concept lingered quietly for generations until Einstein's theory of relativity changed everything. Gravity, Einstein suggested, was not simply a force pulling objects together. Mass actually bends space and time. That single realization opened the door to some of the strangest predictions in modern science. If enough mass collapsed into a sufficiently small region, space-time itself could curve inward so severely that escape would become impossible. Not even light could climb back out. A black hole would form, and strangely, the universe appears surprisingly willing to create them. Many black holes begin with dying stars. When extremely massive stars exhaust their nuclear fuel, they lose the outward pressure that once resisted gravity. Without that pressure, collapse begins. In some cases, the star explodes outward as a supernova, while the core falls inward catastrophically. What happens next is difficult to picture properly. An object larger than the Sun may collapse into a region only a few miles across. Matter becomes compressed beyond ordinary experience. Density rises to astonishing extremes. Gravity intensifies so dramatically that nearby space-time warps inward around the collapsing core. Eventually, a boundary forms, the event horizon, and crossing that boundary changes everything. The event horizon is often described as the point of no return. Once something passes beyond it, escape becomes impossible, because space itself curves inward faster than anything can move outward. Even light, the fastest thing humans know, disappears beyond that edge. But what makes black holes especially unsettling is that the event horizon is not a solid surface. There is no wall, no barrier floating in space. If someone somehow approached a sufficiently large black hole, they might not immediately notice the exact moment they cross the horizon at all. The universe outside would simply begin behaving more strangely with every passing second, and time itself would start changing. One of the most famous consequences of relativity near black holes is gravitational time dilation. The stronger gravity becomes, the slower time moves relative to distant observers. Near a black hole, this effect becomes extreme. To someone watching from far away, an object falling toward the event horizon would appear to slow down gradually, fading redder and dimmer until almost frozen in time. But for the falling observer, time would feel normal. That contrast is deeply unsettling because both perspectives are mathematically valid. Black holes force reality into situations where ordinary human intuition stops working. And then things become even stranger. Near smaller black holes, gravity changes so rapidly across short distances that tidal forces become catastrophic. If a person fell feet first toward one, gravity pulling on their lower body would become enormously stronger than gravity pulling on their upper body. The result has one of the strangest names in astrophysics: spaghettification. Matter stretches into long, thin streams under overwhelming tidal forces. Stars approaching black holes can be torn apart this way too. Modern telescopes have actually observed some of these tidal disruption events. Moments when distant stars wandered too close and were shredded into glowing spirals of gas. For a brief time, the black hole becomes brighter as it feeds. Then darkness returns. And perhaps that is part of what makes black holes feel so eerie. They are invisible until something dies near them. At the center of many galaxies, including our own Milky Way, astronomers believe enormous supermassive black holes already exist. Sagittarius A star, the black hole at the center of our galaxy, contains millions of times the Sun's mass. Yet despite its scale, humans cannot see it directly in ordinary ways because black holes emit no light. Instead, astronomers detect their presence indirectly. Stars near the galactic center orbit something massive and compact. Gas spirals inward and heats intensely before disappearing. Gravity bends surrounding space in ways impossible to ignore. In 2019, humanity finally captured the first image associated with a black hole using the Event Horizon Telescope. The famous image showed a glowing ring surrounding darkness at the center of galaxy M87. The photograph became historic, not because people suddenly saw a black hole itself, but because humanity finally glimpsed the edge of one. The silhouette of gravity. And honestly, the image felt strangely emotional for many people. For decades, black holes existed mostly inside equations, simulations, and imagination. Suddenly, one appeared real. A dark circle suspended inside burning light. Something ancient-looking, almost impossible. But black holes may be stranger still than current observations reveal. Some physicists suspect tiny primordial black holes could have formed shortly after the Big Bang itself. Unlike stellar black holes formed from dying stars, primordial black holes might have emerged from density fluctuations during the earliest moments of the universe. If they exist, some could be incredibly small. Others might contribute to dark matter. So far, no direct evidence confirms this idea, but researchers continue investigating the possibility because it connects black holes to some of cosmology's deepest unanswered questions. And then there is the singularity. At the center of a black hole, current equations predict matter collapses into a point of effectively infinite density where known physics breaks down entirely. Most scientists suspect this description signals incomplete understanding rather than literal infinity, but no accepted theory fully explains what truly happens there. Which means black holes contain regions where humanity's best models of reality stop functioning properly. Not because scientists are careless, because nature itself becomes difficult to describe. Some researchers think quantum gravity theories may eventually explain conditions inside black holes. Others suspect space-time behaves fundamentally differently under such extremes. There are hypotheses involving quantum information, holographic principles, or entirely new physics not yet discovered. For now, the center of a black hole remains hidden behind both gravity and uncertainty. And perhaps that mystery becomes most disturbing when information enters the discussion. According to quantum mechanics, information about physical systems should never truly vanish. But black holes appear capable of erasing information permanently once matter falls beyond the event horizon. That contradiction created what became known as the black hole information paradox. For decades, some of the world's leading physicists argued intensely over whether information can actually disappear from the universe. Stephen Hawking famously proposed that black holes slowly emit faint radiation, now called Hawking radiation, due to quantum effects near the event horizon. Over unimaginable timescales, black holes might eventually evaporate. But what happens to the information trapped inside remains deeply debated. Some theories suggest information escapes subtly through quantum processes. Others propose it remains encoded somehow on the event horizon itself. Certain ideas even imply reality may operate more like a hologram than humans intuitively imagine. The fact these discussions exist at all reveals something extraordinary. Black holes are not just objects in space. They sit at the collision point between gravity, quantum physics, time, and information itself. Almost like stress fractures in reality, where multiple laws of the universe begin conflicting with one another. And still, black holes may not always destroy everything nearby. In some cases, they help create structure. Supermassive black holes at galactic centers appear capable of influencing star formation, shaping surrounding gas clouds, and regulating galactic evolution across billions of years. Some produce enormous jets of energy extending thousands of light years into space. The universe does not seem to treat black holes simply as cosmic vacuum cleaners. They are woven deeply into how galaxies evolve, which creates a strange contradiction. Objects associated with destruction may also help shape creation. There are even theoretical discussions about white holes, hypothetical opposites of black holes, where matter escapes instead of falling inward. No evidence currently confirms their existence, and many physicists remain skeptical. But the idea persists partly because equations sometimes allow strange mirror possibilities under extreme conditions. Wormholes also emerge occasionally in black hole discussions, though evidence for traversable wormholes remains entirely speculative. Still, the mathematics surrounding space-time under intense gravity continues producing possibilities that sound almost fictional. And perhaps that is what makes black holes so captivating. They blur the line between science and the limits of imagination. The closer humanity studies them, the stranger reality appears to become. Even now, astronomers continue discovering black holes larger than earlier generations thought possible. Some quasars, powered by feeding supermassive black holes, already existed surprisingly early in cosmic history, only hundreds of millions of years after the Big Bang. How such enormous structures formed so quickly remains an open question. Again and again, black holes keep pushing astronomy toward deeper mysteries. Not smaller ones, deeper ones. And somewhere inside all of this sits a haunting realization. The universe contains regions where time behaves differently. Light disappears permanently. Matter loses familiar structure, and human understanding becomes incomplete. Not in distant fantasy, in real places scattered across actual galaxies. Perhaps ancient people once feared darkness because they imagined monsters hidden inside it. Modern astronomy removed many old fears from the night sky, but in some ways, it replaced them with something far stranger, because out there in the deep universe, hidden beyond invisible horizons, reality itself may still be collapsing inward into mysteries humanity barely understands. The universe is not truly silent. From the surface of Earth, space often appears calm and motionless. The stars hang quietly above the planet without sound. Galaxies drift invisibly across unimaginable distances. Even violent cosmic events seem strangely peaceful when viewed through telescopes. But beyond human hearing, the universe is constantly producing signals. Bursts, pulses, waves. Repeating patterns crossing the darkness from places so distant, their light began traveling long before human civilization existed. And sometimes, those signals become difficult to explain. One of the strangest moments in the history of astronomy happened on a quiet night in 1977 at Ohio State University. A radio telescope scanning the sky detected an unusually strong signal, unlike anything researchers had seen before. The burst lasted only about 72 seconds before disappearing completely. It never repeated. Yet, the signal appeared so unusual that astronomer Jerry Eman circled the data printout and wrote a single word beside it. Wow! The famous wow signal quickly became one of the most mysterious events in modern astronomy. To this day, nobody knows exactly what produced it. Some scientists suspect a natural cosmic source that simply has not been identified yet. Others think human interference or rare astronomical conditions may explain it. A few continue wondering whether the signal might have been artificial in origin. What makes the mystery endure is not merely the signal itself. It is the silence afterward. The telescope never detected it again. And somehow, a single unexplained burst from deep space became more haunting precisely because it vanished. That pattern appears often in the search for cosmic signals. The universe reveals something strange briefly, then refuses to explain itself further. Fast radio bursts became another example. For years, astronomers kept detecting incredibly powerful radio pulses, lasting only milliseconds before disappearing. Each burst released astonishing amounts of energy, sometimes equivalent to what the sun emits across days or weeks, compressed into fractions of a second. At first, scientists wondered whether the detections were errors. The signals seemed too brief and too intense. Then more appeared. Some repeated. Others never returned. And the deeper researchers investigated, the stranger the phenomenon became. Today, astronomers believe at least some fast radio bursts likely originate from highly magnetized neutron stars called magnetars. But the full picture remains incomplete because different bursts behave differently. Certain signals repeat in patterns. Others appear isolated. A few emerge from surprisingly old regions of space where scientists did not expect such activity. In other words, the universe may be producing multiple kinds of mysterious radio events at once, and humanity is still trying to separate them from each other. The unsettling part is how invisible all of this remains to ordinary human senses. Right now, Earth is being crossed constantly by radio waves from stars, galaxies, pulsars, satellites, and distant cosmic events. Human bodies pass through these signals continuously without noticing. The air around us is already filled with invisible information moving silently through space. Reality is much noisier than it appears. Astronomy simply learned how to listen. One of the first discoveries that truly shocked scientists involved pulsars. In 1967, astronomer Jocelyn Bell Burnell detected a strange repeating signal while studying radio data from space. The pulses arrived with astonishing regularity, repeating every few seconds with precision so exact that researchers briefly considered an extraordinary possibility. Intelligent origin. For a short time, the signal jokingly received the nickname LGM1, meaning little green men. The idea eventually faded once astronomers realized the source was natural. A rapidly spinning neutron star, emitting beams of radiation like a lighthouse across space. Each rotation produced another pulse, yet the discovery revealed something important. Natural cosmic phenomena can sometimes appear artificial before humans fully understand them. And perhaps that is part of what makes the search for extraterrestrial intelligence so difficult. The universe already creates strange signals naturally. Distinguishing between nature and technology may be far more complicated than earlier generations imagine. Even black holes contribute to this hidden cosmic symphony. When matter spirals inward toward a black hole, enormous energies build within surrounding disks of superheated gas. Magnetic fields twist violently. Radiation erupts outward across multiple wavelengths. Some supermassive black holes launch gigantic jets extending thousands of light years into intergalactic space. To human eyes, space looks dark and still. To radio telescopes, parts of the universe are screaming. NASA and other space agencies have occasionally converted electromagnetic data into sound ranges humans can hear, producing eerie audio interpretations of cosmic environments. Technically, sound cannot travel through empty space the way it moves through air. But pressure waves, plasma oscillations, and electromagnetic activity can still be translated into frequencies audible to human ears. The results often sound unsettling. Deep groans, whistles, rhythmic pulses, almost mechanical vibrations echoing through darkness. And although these sounds are scientific translations rather than literal recordings, they trigger something ancient in human psychology. People instinctively search for meaning inside patterns, especially repeating ones. That instinct becomes even stronger when discussing the possibility of alien civilizations. For decades, projects like SETI, the search for extraterrestrial intelligence, have scanned portions of the sky, listening for signals that appear intentionally structured. The logic seems straightforward. Radio waves travel enormous distances efficiently. A technologically advanced civilization might use them for communication. But the search introduces an uncomfortable question. What exactly would an artificial signal even look like? Humans naturally imagine something obvious, perhaps mathematical patterns, repeating prime numbers, or unmistakably engineered transmissions. Yet, extraterrestrial technology, if it exists, may operate in ways humans do not anticipate at all. There is also another possibility. Civilizations may not transmit continuously. Human radio leakage into space has existed for barely more than a century. Already, newer communication technologies often use more focused, efficient systems that leak less radiation outward. A civilization thousands of years more advanced than humanity might become almost invisible, accidentally. The galaxy could contain countless quiet worlds, not dead, just difficult to detect. This idea connects to one of the most unsettling questions in astronomy, the Fermi paradox. Physicist Enrico Fermi famously asked a deceptively simple question. If intelligent life should be relatively common in such a vast universe, where is everybody? The numbers make the silence feel strange. Hundreds of billions of stars exist in the Milky Way alone. Many likely host planets. Some probably possess Earth-like conditions. The universe itself is unimaginably old. Even modestly advanced civilizations could theoretically spread across large portions of a galaxy over immense timescales. And yet, humanity has found no confirmed evidence of extraterrestrial intelligence. No probes, no messages, no unmistakable structures, only silence. Or perhaps not complete silence, because occasionally the universe produces moments that keep the question alive. In 2015, astronomers studying a star called KIC 8462852, often nicknamed Tabby's star, noticed bizarre fluctuations in brightness, unlike ordinary planetary transits. Speculation exploded quickly online. Some proposed giant alien megastructures partially surrounding the star. Most astronomers remained cautious, and natural explanations involving dust now appear far more likely. Still, the excitement surrounding the event revealed something fascinating about human psychology. People want the universe to answer back. Even cautious scientists feel the pull of possibility when something truly unusual appears in the data. And perhaps that longing grows stronger because the cosmos itself already feels strangely alive with hidden communication. Stars emit radiation. Planets reflect signals. Magnetic fields crackle invisibly. Galaxies collide. Neutron stars pulse rhythmically across deep time. Space is not empty silence. It is layered with invisible activity humans evolved too early to perceive naturally. Some of the most powerful signals ever detected come from magnetars, neutron stars possessing magnetic fields so intense they distort atomic structure itself. A single flare from a magnetar can briefly release more energy than the sun emits across hundreds of thousands of years. And these objects exist quietly inside the galaxy, invisible until they erupt. Again and again, astronomy reveals the same unsettling truth. The calm night sky, seen from Earth, hides processes almost unimaginably violent beneath the surface. But perhaps the most haunting possibility is not that the universe contains strange signals. It is that humanity may currently misunderstand most of them. Early astronomers once mistook pulsars for potential alien communication. Future generations may look back at some unexplained signals today and realize the answers were simpler or stranger than modern science currently imagines. Because human understanding of cosmic communication remains extremely young. Radio astronomy itself is barely over a century old. On cosmic timescales, humanity has only just started listening. And there are still regions of the electromagnetic spectrum humans barely explore compared to visible light. Future technologies may reveal entirely new categories of cosmic activity hidden around us all along. The universe could contain layers of information humans simply have not learned how to recognize yet. That possibility changes the feeling of the night sky completely. The darkness above Earth no longer feels empty or quiet. It feels active, filled with invisible transmissions crossing unimaginable distances endlessly through space. Some natural, some unexplained, some perhaps carrying stories from dead stars collapsing galaxies, or violent magnetic storms beyond human comprehension. And somewhere out there, moving silently through the cosmic dark, there may already be signals humanity does not yet understand enough to recognize as important. Which means the greatest mystery may not be whether the universe is speaking, but whether humans are still too young, too limited, or too unprepared to understand what they are hearing. When most people imagine space, they picture stars, bright galaxies, colorful nebulae, endless fields of glowing light stretching through the universe. But some of the most unsettling places ever discovered are not the bright regions. They are the empty ones. The dark spaces between galaxies, where almost nothing exists for unimaginable distances. Regions so isolated that if someone stood there somehow, the night sky itself would barely contain stars at all. And the deeper astronomy explored these cosmic voids, the stranger they became. Because emptiness on the scale of the universe is not simple. It has structure, silence, and possibly mysteries hidden inside it. One of the most disturbing discoveries in modern cosmology is that galaxies are not spread evenly through space. Instead, the universe resembles an enormous cosmic web. Vast filaments of galaxies stretch across billions of light years, while giant empty regions sit between them like holes in reality itself. These regions are called cosmic voids, and some are almost impossibly large. The Bootes Void, one of the most famous examples, spans roughly 330 million light-years across. To understand how enormous that is, light itself, moving faster than anything else in the universe, would need hundreds of millions of years simply to cross it. Inside that vast region, galaxies are extraordinarily rare. Not completely absent, but frighteningly sparse. The first time astronomers realized structures like this existed, the universe suddenly felt less comforting. Because people often imagine space as crowded with stars everywhere. In reality, the cosmos is dominated mostly by separation. Darkness between islands of light. And the farther humanity looks outward, the larger those dark regions seem to become. What makes cosmic voids especially eerie is not merely their emptiness. It is the psychological scale. Even inside galaxies, stars remain separated by enormous distances. Yet galaxies themselves cluster together into groups, superclusters, and long filaments. Humans naturally expect structure to continue consistently across scales. Then the voids appear, almost like missing pieces in the architecture of the universe. Some researchers compare the large-scale structure of the cosmos to soap bubbles or neural networks. Galaxies gather along thin boundaries, while giant hollow regions expand between them. Computer simulations suggest dark matter and gravity gradually shaped this structure over billions of years after the Big Bang. But emotionally, the voids still feel strange. They resemble places where the universe forgot to place anything. And if someone somehow traveled deep into one, the experience would likely feel profoundly unnatural. On Earth, humans evolved beneath skies filled with nearby stars. Even ancient sailors lost at sea still looked upward and saw familiar constellations. But inside a deep cosmic void, entire regions of the sky might appear unusually dark, because neighboring galaxies would sit incredibly far away. The universe itself would feel lonelier, and loneliness becomes a recurring theme in deep space. Astronauts already describe isolation differently after leaving Earth orbit. The farther humans move from the planet, the more fragile and distant civilization begins to feel. Communication delays increase. Earth shrinks into brightness against darkness. Familiar reference points disappear. Now imagine drifting inside a region where even galaxies become scarce. A place where the nearest major structures might lie tens of millions of light years away in every direction. The human mind was never built to emotionally process distances like that. And strangely, cosmic voids may still contain hidden activity despite their emptiness. Tiny dwarf galaxies occasionally appear inside them. Faint gas drifts through some regions. Dark matter likely extends everywhere, even through the deepest voids. Some simulations suggest subtle gravitational interactions continue shaping these enormous spaces slowly across cosmic time. In other words, emptiness itself may still be structured. The voids are not simply nothing. They are extremely thin versions of something. And perhaps that distinction matters more than it first appears. Because throughout astronomy, regions once assumed empty often turned out surprisingly active after better instruments arrived. Dark nebulae eventually revealed star-forming clouds hidden inside them. Black space between stars became filled with radiation, magnetic fields, invisible particles, and wandering planets. The universe repeatedly teaches the same lesson. Darkness is rarely truly empty. Some astronomers even investigate whether cosmic voids might help explain larger cosmological mysteries. A few researchers have explored whether living near a giant, underdense region could influence observations of cosmic expansion, though mainstream cosmology still strongly supports dark energy as the primary explanation. Still, the discussions themselves reveal something fascinating. Humanity's understanding of large-scale space remains incomplete, even now. And the farther outward the universe extends, the stranger its architecture appears to become. One especially unsettling region in astronomy is known as the Great Attractor. Unlike cosmic voids, the Great Attractor represents a hidden gravitational anomaly, pulling galaxies toward it across enormous distances. The Milky Way itself is moving in that direction at incredible speed, alongside countless neighboring galaxies. Yet, observing the region directly became difficult for years because much of it lies obscured behind the dense plane of our own galaxy. Something massive seemed to be waiting beyond the stars. Invisible at first. That detail alone made the discovery feel almost mythological. Entire galaxies drifting toward a hidden destination, buried behind cosmic darkness. Today, astronomers understand more about the structures involved, including large galaxy concentrations, such as the Norma cluster and the broader Laniakea supercluster. But emotionally, the Great Attractor still carries a strange atmosphere, because it reminds humanity that enormous forces continue shaping the universe beyond ordinary perception. Galaxies themselves are not stationary. Everything moves. Everything drifts. Even the Milky Way is traveling through darkness towards structures so massive humans still struggle to fully map them. And beyond these regions lie spaces colder than almost anything imaginable. The average temperature of deep intergalactic space sits only slightly above absolute zero. Tiny traces of radiation remain from the Big Bang itself, creating a faint cosmic background temperature of about -454 degrees Fahrenheit. Cold in space is different from ordinary winter cold. There is no wind, no air, only silence and near-perfect darkness stretching endlessly outward. Objects drifting far from stars eventually become difficult to distinguish from the surrounding void itself. Heat fades away slowly into the cosmic background. Planets without suns may wander invisibly between galaxies for billions of years. Dark, frozen, unseen, and somewhere inside this immense emptiness, collisions still happen. Galaxies crash together over millions of years. Black holes merge. Radiation bursts across space. Entire stars explode silently inside distant regions no human civilization will ever witness directly. The universe does not become peaceful simply because it becomes empty. If anything, the scale makes everything feel more haunting. Perhaps the strangest aspect of cosmic darkness is how much of reality depends on it. Without dark regions between stars, galaxies could not form properly. Without enormous separations, gravity would shape the universe differently. The vast emptiness of space is not accidental background scenery. It is part of the structure itself. And some theories suggest the universe may eventually become even darker. As cosmic expansion accelerates, distant galaxies slowly drift farther apart. Over unimaginable timescales, observers inside surviving galaxies may eventually lose sight of most of the universe entirely. Expansion could carry distant structures beyond observable range forever. Future civilizations, if any still exist, might look into space and see only darkness surrounding their local galaxy, unaware that countless others once filled the cosmos. That possibility feels strangely sad. The universe slowly isolating its own islands of light from each other across eternity. Yet perhaps the most unsettling thing about cosmic darkness is how little humans truly know about it. Astronomers can map galaxies and detect radiation across incredible distances, but enormous portions of the universe remain difficult to observe clearly. Dark matter itself appears invisible. Some regions sit beyond current detection limits. Others may contain phenomena humanity has not learned to recognize yet. Even the observable universe has boundaries created by light speed and cosmic expansion. There are places humans will never see simply because their light cannot reach Earth. Ever. Not because technology is insufficient, because the structure of reality itself prevents it. And beyond that invisible horizon, the universe continues anyway. Possibly forever, possibly infinitely. That realization changes the emotional feeling of the night sky. The stars no longer seem like decorations scattered across darkness. Instead, they resemble tiny, isolated fires surrounded by incomprehensible emptiness extending far beyond human intuition. Ancient people feared dark forests because predators hid beyond the edge of vision. Modern astronomy discovered something stranger. The largest and most haunting regions of existence may not contain monsters at all. Only distance, silence, and darkness so vast that the human mind instinctively struggles to accept it as real. Because somewhere beyond the galaxies visible tonight, there are regions where almost nothing shines for hundreds of millions of light years, and the universe keeps expanding around them. There is a moment in every human life when the mind quietly asks a question almost too large to hold properly. How did all of this begin? Not civilization, not Earth. Everything. The stars above the planet, the galaxies beyond them, space itself, time itself. Every atom inside every ocean, mountain, cloud, and living creature. Somehow, the universe had a beginning, and modern science suggests that beginning was stranger than almost anything humans ever imagined. For most of history, many civilizations assumed the cosmos was eternal. The night sky looked permanent. The stars appeared fixed and unchanging. Even ancient myths that described creation often imagined order emerging from pre-existing chaos rather than absolute beginnings. Then, 20th century astronomy changed the scale of the question entirely. The universe was expanding. Galaxies were drifting away from one another in every direction. The farther astronomers looked into deep space, the faster distant galaxies appeared to recede. At first, the discovery felt almost unbelievable because it implied something extraordinary. If the universe is expanding now, then long ago it must have been smaller, denser, hotter, and eventually, tracing the expansion backward far enough leads toward a state where everything known today existed compressed into conditions almost impossible to visualize properly. This became the foundation of what later came to be called the Big Bang Theory. The name itself sounds explosive, but the reality is more subtle and stranger. The Big Bang was not an explosion occurring inside empty space. According to current understanding, space itself expanded. Every region of the observable universe emerged from an earlier state where matter and energy existed in unimaginably dense conditions. And perhaps the most unsettling part is this: the universe did not expand into anything humans can clearly define. Space itself was stretching, which immediately creates another difficult question. What existed before it? Modern physics struggles there. Not because scientists dislike the question, but because time itself may have behaved differently near the beginning. If time emerged alongside the early universe, asking what happened before the Big Bang may become more complicated than ordinary language allows. Some physicists compare it to asking what lies north of the North Pole. The question itself may partially break down. Still, humans continue asking it instinctively because beginnings feel incomplete without something preceding them. And the universe keeps offering clues while refusing to provide a final answer. One of the most important discoveries supporting the Big Bang appeared accidentally in 1964. Two researchers, Arno Penzias and Robert Wilson were working with a radio antenna when they encountered persistent background noise interfering with observations. At first, they suspected technical problems. They checked equipment. They cleaned the antenna. Famously, they even investigated whether pigeon droppings might be causing the interference. But the signal remained. Eventually, scientists realized they had detected something extraordinary. A faint glow filling the entire universe equally in every direction. The afterglow of the early cosmos itself. Today, this radiation is known as the cosmic microwave background. Ancient light released roughly 380,000 years after the Big Bang, when the universe cooled enough for atoms to form and light could finally travel freely through space. In a way, humanity accidentally discovered baby pictures of the universe. And those images remain deeply haunting. Modern maps of the cosmic microwave background show tiny temperature fluctuations spread across the early cosmos. Slight differences in density eventually became the seeds of galaxies, stars, planets, and everything humans see today. Entire cosmic structures grew from almost unimaginably small irregularities. If the early universe had expanded with perfect smoothness, galaxies might never have formed at all. No stars, no planets, no life, just endless thin gas spreading through darkness forever. That realization makes existence itself feel strangely fragile. The universe appears balanced on incredibly precise conditions. And the deeper cosmology investigates those conditions, the stranger they seem. One especially mysterious period in cosmic history is called inflation. According to current theories, the universe may have undergone a brief but astonishingly rapid expansion fractionally after the Big Bang. During this stage, space itself expanded faster than light across enormous scales. Tiny quantum fluctuations became stretched across the cosmos, eventually helping shape the large-scale structure of galaxies seen today. The idea sounds almost impossible. A universe smaller than an atom, suddenly expanding with unimaginable violence. Yet inflation helps explain several puzzling features of the observable cosmos surprisingly well. Still, important uncertainties remain. Scientists continue debating exactly what drove inflation, whether multiple inflationary events occurred, or whether the process connects to deeper laws of physics not yet understood. And this is where cosmology starts becoming almost dreamlike. Because once inflation enters the picture, some models suggest our observable universe may be only one region inside something vastly larger. A multiverse. Perhaps endless. Perhaps constantly generating new universes with different physical conditions. Not all physicists accept these ideas, and evidence remains extremely limited. But inflationary theories open doors to possibilities earlier generations rarely considered seriously. The observable universe may not be the whole story, which means reality itself could be far larger and stranger than humans currently perceive. Another mystery emerged from something deceptively simple. Matter exists. That may sound obvious, but according to current physics, the early universe should have produced matter and antimatter in almost equal amounts. When matter and antimatter meet, they destroy each other in flashes of energy. So why does anything remain? Why are galaxies made primarily of matter instead of annihilating completely during the early universe. Somewhere near the beginning, an imbalance occurred, a tiny asymmetry. Enough matter survived to build stars, planets, and eventually human beings capable of wondering about the imbalance itself. Modern physics still searches for the exact mechanism behind this cosmic asymmetry. Particle experiments continue probing subtle differences between matter and antimatter behavior, hoping to uncover clues. But for now, existence itself depends on an unanswered question. The universe almost erased itself before it truly began. And perhaps that uncertainty contributes to another strange emotional aspect of cosmology. The deeper humans explore the origin of reality, the less inevitable existence appears. Even time feels fragile near the beginning. Near the earliest moments after the Big Bang, known physics begins breaking down under extreme temperatures and densities. Gravity, quantum mechanics, and space-time become difficult to reconcile cleanly. Scientists suspect a deeper theory, perhaps quantum gravity, eventually may describe those conditions more accurately. For now, however, humanity stands near a boundary of understanding. A horizon beyond which equations become incomplete. And beyond that horizon, speculation begins. Some theories suggest the universe may cycle endlessly through expansions and collapses. Others propose black holes could potentially generate new universes internally under certain conditions. A few physicists explore whether our universe emerged from quantum fluctuations inside a larger cosmic framework. There are even philosophical discussions about whether the laws of physics themselves evolved over time. None of these ideas currently possess definitive proof. But the fact serious scientists investigate them at all reveals how mysterious cosmic origins remain. The Big Bang Theory explains enormous amounts about how the universe evolved after its earliest moments. It does not necessarily explain why reality exists in the first place. And perhaps no discovery illustrates the scale of cosmic history more clearly than starlight itself. When humans look into deep space, they look backward through time. Light from distant galaxies may travel billions of years before reaching Earth. Some galaxies visible tonight appear as they existed long before the Sun formed. Telescopes effectively become time machines aimed into the past. The James Webb Space Telescope recently deepened this feeling dramatically by revealing galaxies from surprisingly early periods of cosmic history. Some appeared more developed than expected based on earlier models, prompting astronomers to reconsider aspects of galaxy formation in the young universe. Again, the cosmos revealed something slightly stranger than predicted. That pattern never fully disappears in astronomy. Every answer seems to expose deeper layers underneath. And perhaps the most unsettling mystery of all is that the universe became capable of observing itself. Atoms formed inside stars. Stars created heavier elements. Planets emerged from cosmic debris. Life evolved on at least one world. Eventually, conscious beings appeared and began asking questions about the origin of reality itself. The universe somehow produced minds capable of studying the universe. That fact alone feels almost impossible when viewed from far enough away. A species living briefly on a small rocky planet somehow learned to detect radiation from the beginning of time. And yet, despite all this progress, enormous mysteries remain untouched. What triggered the Big Bang? Why do physical laws possess the values they do? Is our universe unique? Does time have a true beginning? Will humans ever fully understand the deepest structure of existence? No one knows. Perhaps no one ever will. Because the closer cosmology approaches the beginning of everything, the more reality begins feeling less like a machine and more like a profound mystery humans are only partially equipped to comprehend. The stars above Earth no longer appear eternal once their origins are understood. They become temporary structures born from ancient cosmic processes stretching back nearly 14 billion years. And somewhere beneath all of it, beneath galaxies, black holes, dark matter, and expanding space itself, remains the oldest unanswered question of all. Why is there something instead of nothing? For most of human history, the question felt almost impossible to answer. Are we alone? Ancient people looked into the night sky and imagined gods, spirits, celestial kingdoms, or distant fires beyond human reach. Later, science replaced mythology with planets, galaxies, gravity, and chemistry. But even as telescopes revealed the structure of the universe, the question remained strangely untouched beneath everything else. Somewhere out there, beyond Earth, could life exist? And the more modern astronomy learned about the cosmos, the less impossible the idea began to seem. Because the universe appears filled with worlds. Not dozens, not thousands, possibly trillions. Some orbit quiet stars. Some drift frozen through darkness. Some may hide oceans beneath thick layers of ice. And somewhere among those countless environments, chemistry may have crossed the invisible boundary between non-living matter and life, perhaps many times. The strange thing is that scientists no longer ask whether the ingredients for life exist elsewhere. They clearly do. Water appears surprisingly common across the cosmos. Organic molecules drift through interstellar clouds. Carbon chemistry emerges naturally in space. Even comets and meteorites contain complex compounds connected to biology. The universe already knows how to build the pieces. The deeper mystery is whether those pieces assemble into something alive often enough for life to spread widely through the galaxy. And Earth itself may contain clues. For a long time, humans assumed life required gentle conditions, similar to ordinary environments on the surface of our planet. Moderate temperatures, sunlight, stable weather. Then biology discovered extremophiles, microorganisms surviving in places that once seemed completely uninhabitable. Some bacteria live near hydrothermal vents, deep beneath the ocean, where temperatures approach boiling and sunlight never reaches. Others survive inside Antarctic ice, acidic lakes, radioactive environments, or rocks buried far underground. Life, it turns out, is disturbingly adaptable. That realization changed astrobiology completely. Because if life can survive in Earth's most extreme environments, then many alien worlds, once dismissed as sterile, suddenly become more interesting. One of the most fascinating examples sits beneath the frozen surface of Jupiter's moon, Europa. From the outside, Europa appears cold and lifeless, a smooth shell of cracked ice drifting through darkness around Jupiter. But beneath that frozen crust, scientists strongly suspect a vast global ocean may exist. An ocean potentially containing more water than all of Earth's oceans combined. And hidden beneath miles of ice, tidal forces generated by Jupiter's gravity may create heat deep inside the moon. Some researchers even suspect hydrothermal activity could occur along Europa's sea floor. In other words, Europa might contain water, energy, chemistry, and long-term stability, ingredients many scientists consider essential for life. The unsettling part is imagining what could evolve in such a place. No sunlight, no sky, only darkness beneath ice stretching endlessly overhead. If life exists there, it may have developed completely isolated from stars. And Europa is not alone. Saturn's moon, Enceladus, became another major focus after spacecraft detected enormous plumes of water vapor erupting from cracks near its south pole. Those plumes contained salts, organic compounds, and evidence suggesting warm water interacts with rock deep beneath the surface. An ocean hidden inside a frozen moon was already surprising. An active ocean venting material into space felt even stranger, because suddenly, scientists no longer needed to drill through miles of ice to sample the moon's interior. Enceladus was already spraying pieces of its hidden ocean outward naturally. And perhaps somewhere inside those dark waters, chemistry has gone further than humans realize. Titan, another moon orbiting Saturn, may be stranger still. Unlike Europa or Enceladus, Titan possesses a thick atmosphere and stable liquid on its surface. But the lakes and rivers there are not made primarily of water. They contain methane and ethane, liquid hydrocarbons flowing beneath an orange alien sky. Temperatures on Titan are brutally cold, far below anything humans could survive naturally. Yet some researchers wonder whether forms of chemistry unfamiliar to Earth biology might operate there, slowly, over immense timescales. Not necessarily intelligent creatures, perhaps not even recognizable organisms, but maybe something, some process balancing between chemistry and life. The possibility forces scientists into an uncomfortable realization. Human beings only know one example of life: Earth life. Everything humans consider normal biology comes from a single evolutionary history. DNA, proteins, water-based cells, all connected to one planetary origin. But the universe may not be obligated to repeat Earth's design exactly elsewhere. Alien life could differ in ways humans barely anticipate. Some theories explore the possibility of silicon-based life rather than carbon-based chemistry, though many scientists remain cautious because carbon appears especially versatile chemically. Others imagine organisms living in subsurface oceans, floating through gas giant atmospheres, or surviving around hydrothermal systems completely disconnected from sunlight. The universe keeps widening the definition of what might be possible. And at the same time, the silence remains. Despite decades of searching, humanity still possesses no confirmed evidence of extraterrestrial life. No fossils from Mars. No alien microbes beneath Europa's ice. No signals undeniably artificial. Only possibilities. And perhaps that uncertainty feels especially haunting because Earth itself formed relatively early compared to the future lifespan of the universe. Some stars will continue burning for trillions of years. Civilizations far older than humanity could theoretically already exist somewhere. Even simple microbial life emerging commonly across planets would imply biology may be widespread throughout the cosmos, which leads directly back to the uncomfortable question many scientists quietly wrestle with. If life should be common, where is everybody? The Fermi paradox grows stranger the larger the universe becomes. Modern astronomy has revealed countless planets. Some appear potentially habitable. Organic chemistry seems widespread. The raw ingredients for biology exist almost everywhere scientists look. And yet Earth remains silent. No visitors. No confirmed transmissions. No visible galactic civilizations reshaping stars or galaxies in obvious ways. Only darkness. Some researchers think intelligent life may simply be extremely rare. Others suspect civilizations tend to destroy themselves before spreading far into space. A few propose advanced societies might intentionally remain quiet. That last idea became known through something called the dark forest hypothesis. The concept is unsettling. In a universe where civilizations cannot easily know each other's intentions, broadcasting your location might become dangerous. Every civilization could remain silent out of fear, hiding among the stars like hunters moving quietly through a dark forest. The theory remains speculative, of course, but emotionally it resonates because the universe already feels enormous, ancient, and difficult to trust fully. Silence itself begins feeling meaningful. At the same time, there may be simpler explanations. Interstellar distances are almost unimaginably large. Even light takes years to cross between nearby stars. Civilizations may rise and disappear across timescales too brief to overlap. Humanity's own technological era has barely lasted more than a century. On cosmic scales, humans have only just begun making noise. And the search continues. Mars remains one of the most closely studied worlds, partly because evidence suggests liquid water once flowed across its surface billions of years ago. Ancient river valleys, lake beds, and mineral deposits reveal that early Mars may have been far warmer and wetter than the cold desert seen today. Some scientists think microbial life could potentially have emerged there during that ancient era. If so, what happened afterward? Did life disappear completely? Retreat underground? Or perhaps never begin at all? Rovers continue exploring these questions slowly, grain by grain, across the Martian surface. And meanwhile, telescopes search distant exoplanets for atmospheric clues. Oxygen, methane, chemical imbalances potentially hinting at biology. The James Webb Space Telescope and future observatories may eventually detect stronger evidence from worlds dozens or hundreds of light years away. Not cities or spacecraft, more subtle signs. Alien weather, alien oceans, alien atmospheres changed by living processes. And perhaps the strangest emotional shift in modern astronomy is this: humanity no longer seems separated from the universe. For centuries, Earth felt isolated, a single inhabited world surrounded by unreachable stars. Now, the cosmos appears biologically possible almost everywhere scientists look. Maybe life is rare. Maybe it is common. Maybe microbial organisms fill the galaxy, while intelligent civilizations remain scarce. Or perhaps advanced civilizations exist so far beyond humanity technologically that people would struggle even to recognize their presence. The truth remains hidden, but the universe itself feels less empty now. Because once humans understood how many planets exist, how resilient life can become, and how naturally chemistry organizes itself across space, the old assumption of cosmic loneliness became harder to defend confidently. And perhaps, somewhere tonight, beneath another atmosphere orbiting another star, a different species is looking upward with the same uncertainty, wondering whether they are alone too, listening to silence, watching distant lights, and asking questions large enough to follow consciousness across the entire universe. The stars above Earth feel permanent. For thousands of years, humans looked into the night sky and saw the same constellations returning season after season. Ancient civilizations rose and disappeared beneath them. Empires collapsed. Oceans were crossed. Entire religions formed under familiar stars that seemed eternal and unchanging. But the universe does not build eternal things, not even stars. Every light in the sky is living through a lifespan measured across unimaginable stretches of time. Some are young and unstable. Some are already dying. Others vanished long ago, their final light still traveling silently through space toward Earth. And eventually, every star reaches an ending. The strange part is that stars die in wildly different ways, depending on how massive they become. Small stars fade slowly and quietly. Giant stars collapse violently enough to briefly outshine entire galaxies. In many ways, the future of the universe is really the story of how its stars disappear. Our own sun appears calm from Earth. Sunrise feels reliable. Sunlight feels stable and ordinary. Yet deep inside the sun, enormous nuclear reactions continuously fuse hydrogen into helium every second. That process releases the energy, warming oceans, driving weather, and allowing life to exist at all. But even the sun is temporary. Right now, it sits roughly halfway through its main lifespan. Scientists estimate it will continue burning relatively steadily for around 5 billion more years before entering a very different phase of existence. And the transformation will not be subtle. As hydrogen gradually becomes depleted inside the sun's core, the balance between outward energy and inward gravity will begin changing. The core will compress. Temperatures will rise. The outer layers of the sun will expand enormously outward. The sun will become a red giant. And when that happens, the inner solar system may become almost unrecognizable. Mercury will likely disappear entirely. Venus almost certainly will as well. Earth's fate remains more complicated because orbital changes and solar mass loss create uncertainties over immense timescales. But even under optimistic models, Earth itself would become catastrophically hostile long before any possible physical engulfment occurs. The oceans would evaporate. The atmosphere would change violently. Surface temperatures would climb beyond survival. The strange thing is that this process is not unusual. Across the galaxy, countless stars are already entering similar final stages. Astronomers regularly observe red giants swelling outward like dying embers across space. Some become so enormous that if placed at the center of our solar system, they would extend past the orbit of Mars. The universe is filled with stars, quietly approaching old age. And eventually, stars like the sun shed their outer layers into space, creating glowing clouds called planetary nebulae. Despite the name, these structures have nothing to do with planets. Early astronomers simply thought they resembled distant planetary disks through primitive telescopes. In reality, they are stellar remains, the final visible breath of dying suns. At the center, a dense white dwarf remains behind, an object roughly comparable to the sun's mass, compressed into a size similar to Earth. These white dwarfs no longer generate major fusion reactions. Instead, they slowly cool across trillions of years. Tiny stellar corpses radiating leftover heat into darkness. And some stars die far more violently. Massive stars live shorter lives because they burn through nuclear fuel astonishingly quickly. The largest stars consume themselves at extraordinary rates, creating heavier and heavier elements inside their cores over time. Hydrogen becomes helium. Helium becomes carbon. Carbon becomes oxygen and heavier elements. Eventually, iron forms. And iron changes everything. Unlike lighter fusion reactions, fusing iron does not release energy efficiently enough to support the star against gravity. Once too much iron accumulates in the core, collapse begins catastrophically. Within seconds, the star implodes inward, then explodes outward in one of the most violent events in the universe. A supernova. For brief periods, supernovae can outshine entire galaxies containing billions of stars. The explosion blasts heavy elements across surrounding space: gold, uranium, calcium, iron, oxygen, many of the materials later incorporated into planets and living organisms. In a very literal sense, human bodies contain matter forged inside dead stars. Ancient supernova explosions helped make Earth possible. That realization changes how death itself feels in cosmology. Stars do not simply disappear. They transform the universe around them. Sometimes, supernovae leave behind neutron stars, objects so dense that ordinary intuition breaks down completely. A teaspoon of neutron star material would weigh billions of tons on Earth. Matter becomes compressed beyond anything humans experience naturally. And some neutron stars spin rapidly enough to produce rhythmic pulses detectable across space. Pulsars. Cosmic lighthouses drifting through darkness long after the original star vanished. But if the collapsing core becomes massive enough, gravity overwhelms everything entirely. A black hole forms. The death of one star creates a region where light itself cannot escape. And somewhere across the cosmos tonight, stars are collapsing invisibly, while black holes continue growing in darkness. Yet even galaxies themselves are temporary. The Milky Way and the Andromeda Galaxy are slowly moving toward one another right now at hundreds of thousands of miles per hour. The collision will not happen soon by human standards. Roughly 4 billion years remain before major interaction begins. But on cosmic timescales, the event is already unfolding. The word collision sounds violent, but galaxies are mostly empty space. Individual stars likely will not crash directly into each other often. Instead, gravity will slowly distort both galaxies across millions of years. Stars will shift positions. Gas clouds will collapse into bursts of new star formation. The night sky from future planetary systems may look completely unfamiliar. Eventually, the Milky Way and Andromeda may merge into a single larger galaxy, sometimes nicknamed Milkomeda. Even galaxies possess life cycles, and the farther astronomers project the future outward, the stranger the universe becomes. Right now, stars still form actively throughout many galaxies. Giant molecular clouds continue collapsing into new stellar systems. But star formation cannot continue forever. Over immense stretches of time, galaxies gradually consume or disperse the gas needed to create new stars. The universe is slowly using up its light. Trillions of years from now, many remaining stars may be small red dwarfs, dim, long-lived stars capable of burning for extraordinary lengths of time. Some red dwarfs may survive for trillions of years longer than stars like the Sun, which creates an eerie image of the far future universe. A darker cosmos illuminated mostly by tiny red stars drifting through expanding space. Eventually, even those will fade. White dwarfs will cool into black dwarfs, though the universe may not yet be old enough for any true black dwarfs to exist today. Neutron stars will drift through darkness. Black holes may dominate many surviving structures. And then comes one of the strangest predictions in cosmology. Black holes themselves may not last forever either. Stephen Hawking proposed that quantum effects near event horizons allow black holes to emit faint radiation gradually over enormous timescales. This Hawking radiation would cause black holes to lose energy slowly and eventually evaporate. The process is unimaginably slow for large black holes. A supermassive black hole might survive for numbers of years so vast they barely fit inside ordinary language. But eventually, according to current theory, even black holes may disappear. which leads toward one possible vision of the universe's ultimate future: the Big Freeze. In this scenario, cosmic expansion continues accelerating forever. Galaxies drift farther apart. Star formation ends. Existing stars burn out. Matter decays slowly across enormous stretches of time. Temperatures approach near absolute zero as the universe grows darker and emptier. Not an explosion, not sudden destruction, a gradual fading. The cosmos becoming colder, quieter, and more isolated across eternity. Some alternative theories still exist. A few models explore cyclic universes where expansion eventually reverses into collapse. Others investigate possibilities involving vacuum decay or exotic changes in dark energy behavior. Modern evidence currently favors continued expansion, but cosmology remains incomplete enough that uncertainties still matter. The future of the universe is not fully settled, and perhaps that uncertainty itself feels strangely human. Because humans also live inside temporary structures while searching for meaning against enormous stretches of time. The stars above Earth feel immortal only because human lives are short. In reality, the cosmos changes constantly. Stars are born. Stars die. Galaxies merge. Black holes evaporate. Even the universe itself evolves. And somehow, inside this vast cycle of endings and transformations, consciousness emerged, briefly, on one small planet orbiting one temporary star. A species capable of realizing that even the night sky is mortal. Perhaps that is what makes astronomy feel emotional in ways difficult to explain fully. The universe is beautiful, partly because it does not last forever. Every glowing star overhead is living through a moment. Every constellation belongs to a temporary arrangement. And somewhere deep in the future, long after Earth is gone and the sun has faded into darkness, the universe will continue drifting through colder and quieter ages humans can barely imagine now. Still expanding, still changing, still carrying the fading light of ancient stars across the endless dark. Long before telescopes, before science, before cities, before written language, human beings were already looking upward. Somewhere in the distant past, an early human stood beneath a dark sky, untouched by artificial light, and noticed something impossible to ignore. Thousands of stars stretched overhead. The moon changed shape night after night. Meteors crossed the darkness without warning. Strange wandering lights moved differently from the fixed stars around them. And for reasons nobody fully understands, humans never stopped caring. That may be one of the oldest continuous behaviors in human history. Looking up. Across thousands of years, civilizations changed completely. Languages disappeared. Religions transformed. Entire empires vanished beneath the same sky. Yet generation after generation kept returning to the stars, as though the universe itself was asking a question too large to ignore. Even now, after everything modern science has discovered, people still step outside at night and stare upward quietly. And perhaps the strangest part is that the stars still affect us emotionally, despite knowing what they are. Modern astronomy removed many ancient illusions. The constellations are not divine creatures. Comets are not supernatural omens. The Milky Way is not a river of souls stretching across heaven. And yet somehow, the night sky did not become less beautiful after science explained it. In many ways, it became more haunting because humans learned the stars are real places, some larger than the sun by unimaginable scales, some already dead before human civilization began, some surrounded by planets drifting through alien weather beneath skies no human being may ever touch. The universe became colder scientifically, but emotionally it became deeper. Psychologists sometimes study something called the overview effect, a cognitive shift experienced by astronauts after seeing Earth from space. Many describe a sudden emotional realization that borders, conflicts, and ordinary human concerns appear strangely temporary when viewed against the scale of the cosmos. Earth becomes small, fragile, bright against overwhelming darkness. Several astronauts struggled to explain the feeling afterward because it seemed less intellectual than emotional. Some described awe. Others described grief, connection, loneliness, or profound clarity. And perhaps humans have always experienced smaller versions of that feeling beneath the stars. The night sky changes perspective. A person worrying quietly beneath a galaxy suddenly realizes the universe existed long before them and will continue long after them. Strangely, that realization can feel terrifying and comforting at the same time. Because the cosmos makes human life seem both tiny and meaningful simultaneously. Tiny in scale, meaningful because consciousness exists at all. That paradox may explain why astronomy became connected to philosophy almost immediately throughout history. Ancient people did not merely observe the heavens for navigation or agriculture. They asked existential questions through the stars. Where did we come from? Why are we here? What happens after death? Are humans alone? In some ways, modern cosmology still circles the same questions using different language. The tools changed. The mystery remained. And perhaps the mystery feels permanent because human beings evolved inside a universe too large for intuitive understanding. The brain handles forests, rivers, storms, faces, voices, and physical survival reasonably well. But cosmic scales break ordinary perception almost instantly. Distances between stars become difficult to emotionally process. Billions of years stop feeling real. Infinite space slips beyond imagination entirely. Yet humans continue trying anyway, again and again. Perhaps because curiosity itself became part of survival long ago. Early humans who explored, questioned, experimented, and searched beyond immediate surroundings often discovered food, shelter, safer territory, or new tools. Over immense stretches of evolution, curiosity may have become deeply tied to human cognition itself. But curiosity about the stars feels different from ordinary survival. Nobody needed galaxies to hunt animals. Nobody needed black holes to build villages. And yet astronomy became one of humanity's oldest obsessions anyway. Maybe because the sky offered the first visible evidence that reality extended far beyond human life. The stars hinted that the world was larger than immediate experience. And once humans sensed that possibility, it became impossible to fully ignore. Even modern technology has not weakened this instinct entirely. Cities covered the night in artificial light. Many people now grow up seeing only a fraction of the stars visible to earlier generations. Phones, screens, and modern schedules keep attention focused downward constantly. Yet when people travel somewhere truly dark, deserts, mountains, isolated coastlines, and see the Milky Way clearly for the first time, the reaction is often immediate. Silence, awe, sometimes even tears. Because beneath all modern distractions, the ancient emotional response still survives. Humans remain creatures shaped by the sky, and perhaps that connection deepened because the universe itself created us, literally. The calcium inside human bones formed in ancient stars. Iron inside blood emerged through stellar fusion and supernova explosions long before Earth existed. Every atom heavier than hydrogen ultimately came from cosmic processes unfolding across billions of years. Human beings are not separate from the universe observing it. In a very literal sense, the universe became conscious enough to look back at itself. That realization changes astronomy from a distant science into something strangely intimate. The stars are not merely objects overhead. They are part of the same long cosmic story that eventually produced oceans, forests, animals, and human minds capable of wondering about existence. And still, despite everything science has discovered, the sky remains emotionally mysterious. Perhaps because knowledge does not eliminate wonder the way people sometimes expect. Understanding black holes mathematically does not make them emotionally ordinary. Knowing stars are nuclear furnaces does not make a clear night feel less beautiful. Learning the age of the universe does not remove the strange feeling humans experience when staring into deep space quietly. If anything, scientific understanding often amplifies the mystery. Because reality turned out stranger than mythology in many ways. Invisible matter shapes galaxies. Time slows near black holes. The observable universe may contain trillions of planets. Space itself expands. Most of existence remains unseen, and somewhere beyond human observation, the cosmos continues doing things nobody on Earth fully understands yet. That unfinished quality may matter deeply. The universe still contains mystery, even now. Perhaps especially now. For centuries, humans imagined science as a process that would eventually explain everything completely. But modern cosmology often produces the opposite feeling. Every answer exposes deeper questions underneath. Dark matter explains galactic behavior, while introducing invisible mass nobody fully understands. The Big Bang explains cosmic expansion while leaving the origin of existence unresolved. The search for extraterrestrial life reveals countless potentially habitable worlds while providing no final answer about whether humanity is alone. Knowledge keeps widening the horizon of mystery rather than closing it. And maybe that endless horizon explains why people never stop looking upward. The sky always contains another question, another possibility, another layer beyond current understanding. Even children instinctively ask enormous cosmic questions surprisingly early. What are stars? How big is space? Does the universe end? What happens beyond it? Those questions appear naturally because the human mind struggles with boundaries around reality itself. The universe feels too large to fully accept and too beautiful to ignore. So humans keep returning to it. Artists paint it. Scientists study it. Poets describe it. Religions interpret it. Travelers navigate beneath it. Lovers sit quietly under it. Lonely people stare into it, searching for perspective. Entire civilizations organize time around its movements. And somewhere in the future, humans may eventually stand on distant planets beneath unfamiliar constellations while asking the same ancient questions again. The stars will change. The curiosity probably will not. Because beneath all technology, politics, and history, human beings remain aware of something extraordinary. We exist briefly inside a universe far older, larger, and stranger than ourselves. And somehow, against overwhelming odds, consciousness appeared long enough to notice it. Perhaps that alone is enough to explain why humans never stop looking up. Not because the universe gives easy answers, but because it gives something deeper. Perspective, wonder, mystery, a reminder that beyond every city, every lifetime, and every ordinary human worry, there is still an endless sky filled with ancient light traveling silently across the dark. And tonight, just like every generation before us, humans are still beneath it, searching for meaning among the stars. Thanks for spending this time exploring the universe with me tonight. If you enjoyed this relaxing journey through space, don't forget to subscribe and leave a comment below telling me what mystery you'd like to explore next. I'd love to hear your ideas. Wishing you a peaceful night, good health, good luck, and a deep, relaxing sleep tonight.